We're recording? Cool. All right. Well, everybody, welcome back to the latest Collision Hub webinar with AirPro Diagnostics. And we're together. We're not in Florida and
doing our best to
Chicago.
social distance. We're doing our best to get it done.
We're not quite achieving 6 feet, but we'll do what we can.
You guys been good?
We
have
been
this
good.
okay?
Yeah, it feels good to get out of my house.
Well, it's great to have you guys here with us today. Great to have all of you with us here today as well. This is our latest in an ongoing series with AirPro Diagnostics. And today we're going to talk about specifically about calibrations and the importance of calibrations. So we've talked a lot about just the general collision repair diagnostic process. Scanning the vehicle, getting diagnostic trouble codes, some of the required research after that. Looking at the codes, trying to figure out what exactly we're dealing with. We talked about technician strengths and skills, and we talked a little bit about calibration. But today we're going to hit a little bit harder and really talk about how to lay out some targets. Talk about different types of targets, some of the common mistakes that can go wrong, and any else that things come on. We're using the webinar feature today, so if you have any questions that you like answered, please use either the Q&A feature or you can use the chat feature as well. So if you do have something you want to comment in and ask a question, go ahead and raise your hand, but I would like to stick to the Q&A and chat today, a little bit more manageable, I think, for us rather than trying to kind of talk to somebody remotely today. But so go ahead and use that throughout, and we'll take a couple breaks throughout, and we can answer if anybody has any questions. I'll try to keep an eye on our big board over here and answer questions as they come in. But full disclosure, so we've got this Toyota RAV4 here behind Josh that we're working on today. Now, this vehicle has not been repaired. Okay, this vehicle is in a collision. Got some right front damage, so it's going to need a new bumper. We're going to be putting a bumper on this. But we're going to actually calibrate the vehicle, but we want to walk through the calibration process and how to lay out the targets. That's kind of the actual calibration process itself. A lot of times is pushing a continue button and kind of towards the end of the process and letting the systems talk themselves. But I think where the sticking point we get into really is the stuff we want to talk about, getting at the right distance and the right height and plumb bob and everything else. So again, this vehicle has not been repaired yet, but it will be. So we're going to go on the scenario of we just got done R9 this bumper, and now we need to go ahead and do the calibration. So that work for you guys?
Sounds good to me.
Yeah. Okay, cool. So, all right. So what's our first step in this process? What are we looking at?
Well, first is the identification that it actually needs a calibration, right? This is a fairly simple repair to the naked eye. I mean, we haven't done our strategic disassembly yet. We haven't taken a look at the back end of it, assuming we're in the front end of the process, right? But with the Toyotas, specifically, their radar is quite often mounted either to the grill or bumper, which are typically attached, right?
Yep.
So the thought process in many repair facilities is, I'm just replacing the bumper. I didn't do anything to the radar. I didn't move it outside of where it originally was. I'm good to go. Well, if you look up the procedures, that's surely not the case, right? It needs to be calibrated. So we've identified this is going to need a calibration. We've repaired the vehicle. We've put it back together. So in my mind, Josh, I think that the very first step is to look up the procedure. And
always a great first step.
And see what it takes to actually get done. Right?
So you're saying that even though all we're going to do is replace this bumper cover, we've still got to do a calibration.
Yeah, absolutely. Anytime you
all we're doing is taking it off and putting it back on again.
I get it. Anytime you manipulate the original setting from the manufacturer of the module, the radar, you have to ensure that it is calibrated as per the recommendations from the manufacturer.
So let's talk a little bit more about that. Okay, so now granted that's the Toyota recommendation for this particular vehicle, R9 bumper or damage or whatever. What are some other scenarios that may require me to do aiming, calibration? Let's walk just through a couple of different other examples.
Yeah, I think you could start with the simple R&I, right? We all know that there are a lot of manufacturers that have 360 view in the mirrors, right? You detrim a door for something as simple as a blend, you're manipulating the original position of that camera, right? I'd say any kind of R&Is, those are big ones that are missed out there because they're not actually working on that specific area of the vehicle. So the assumption is that everything's okay.
Yeah, it's the original camera or the original sensor,
right?
The original wiring. All I've done is unbolt it and bolt it back on again.
Right.
It went right back where it was.
Yeah, but we
got to calibrate it.
Got to calibrate it. They work off of millimeters, right? Millimeters when it comes to
they're small.
Very small.
Millimeters, right?
But from far away, those millimeters become feet.
Oh,
right?
okay.
And feet could essentially mean the difference between
Sure.
life or death and a subsequent crash.
Absolutely. There's no doubt about that. So I'm backing out of the garage. I got 360 cameras, and I bumped the mirror. Probably have to calibrate that. Probably put it back in.
Yeah.
I get a crack in my glass. I get new glass put in there. I've got forward-facing camera. Probably calibration.
Absolutely. I think glass is, as we've done our research through the market, that's one of the most missed calibrations out on the road today. You know, simple glass R&I, maybe you're repairing a roof or something like that where the glass has come out simplistically for paint reasons. Well, there's nothing wrong with the glass. And in some cases, the cameras are mounted to the glass. So the assumption is by the shop, again, it wasn't worked on. It's going right back to its original position. No need for a calibration. And I don't think couldn't be further from the truth.
Well, and you don't know that it's in the original position, right? You don't know it. You may not have bumped it a little bit. You may have, accidentally, nudged something, or who knows it. And the thing that I think where a lot of the confusion comes around is, well, why won't it give me a diagnostic trouble code or turn on a malfunction indicator lamp if there's something wrong with the system? Well, the system doesn't know anything's wrong because it's a camera and it's seeing something, correct?
Correct.
Or it's a sensor and it's sensing something, correct? So there's no way for the system to know that it's not in the right location. Is that accurate to say?
I think that's accurate to say. I'd add to that there's also I think a mindset within the vehicle manufacturers that if they don't need to turn that light on because it's not affecting the life of the vehicle or the ultimate safety of the customer and that sort of thing, they try to keep that light off. They don't want the vehicle coming in for service, every time there's any kind of little hiccup. They want it to come in when it's really necessary.
Yeah.
And so I don't want to make it sound like I'm dogging on the vehicle manufacturers. That's not the intent. It's just they've made a business decision that they want to keep that light off as long as possible.
Sure. They've
got good reasons for that. And so the light stays off as long as they can rationalize keeping that light off.
And a lot of times I know I've driven in vehicles with adaptive cruise control, for example, in a snowy or slushy condition where I'll get snow or slush built up on the front of the bumper cover, and it'll say like, hey, your adaptive cruise control is no longer available, or I got a lot of blind spot, is no longer active because of rain. If that tripped the code every time and it gave me a light on the dash every time, how would that go away?
Sure.
So I think there's a lot
especially with something like that where it's going to resolve itself more than likely, because you're going to go through a car wash, or the ice is going to melt off, or something like that, and that issue is going to resolve itself. And in many cases, when you're talking about the manufacturer, they've got redundant systems. So, one of the reasons they may not put the light on is because they know I've got this other system that's allowing me to keep the vehicle and the driver safe through these other means, because ultimately it's still the responsibility of the driver to drive the vehicle.
Sure.
Okay,
so we talked, we've got, again, we've bumper R&I, glass R&I, mirrors, other damage. I've seen certainly as well, if there's a lift, put a lift kit on a vehicle. A lot of trucks have lift kits on them, or bigger tires. I change the tire size, the wheel diameter. Those are going to often require calibration. I know that this calibration and aiming issue is big for the aftermarket, like SEMA crowd, because again, lots of big trucks, lots of big wheels, lots of big tires there, and as it becomes more popular on a lot of vehicles, automatic emergency braking being standard in 2022. Those vehicles are going to have them, and even those accessories when I lift the truck, I'm going to have to deal with that.
Well, even if you haven't done any of that and you've just got a fleet vehicle where they're going to do more time off-road or in rougher environments, oftentimes they will put brush guards or bumper guards of some sort on the front of the vehicle. That's going to get in the way of something, more than likely.
Oh, yeah.
Or I don't know when the last time you went through New York City was, but New York City, there's an awful lot of cars that now have a bumper guard on the front and rear of the vehicle that is just there to allow them to get into that spot and push the other car out of the way, right? So they're on almost everything, and they're right in front of park sensors. They're right in front of radar sensors in the front, et cetera, et cetera.
So the OEMs, how are they letting me know that I need to calibrate this particular system? Where am I going to find that information? Am I going to find it when I'm R&Ing the bumper, or is it going to tell me to calibrate that?
No, you're going to find it in your SI, right? You got to look up your procedures just with any other repair. We're not just revolving ADAS either. If you're replacing a frame rail, suspension, anything you're doing within the repair process should be researched and documented. And when I say documented, proof that you've done it correctly.
Yeah.
Right. So that's really the only place you're going to find whether it does or does not require calibration based on what you're doing to the vehicle.
So I'm going to go through that OEM procedure. I'm going to RNI this bumper, and it's going to say if it's got intelligent cruise, if it's got adapters control, if it's got lane keep assist, it's going to tell me you must perform
XYZ
this procedure. Okay,
yeah.
Cool. So, all right, let's talk a little bit about our RAV4 here. So we've already got some of this stuff set up. So let's walk through, we'll kind of work our way from the vehicle over to our target here. So from the vehicle, what's kind of some of the first things that we need to do on a Toyota vehicle, for example?
Yeah, so the first thing you want to do, obviously we talked about pulling the procedures.
Yep.
Okay, then the next step is to verify that you have the space and the environment to perform this calibration. Okay. Whether it be through a radar or a camera, there are very specific space requirements and environment requirements that will allow you or not allow you to perform. So in this specific instance, we've measured off, we have the necessary area in front of the vehicle free of any metal. You know, one of the challenges out there is people are looking at their space within the shop. A lot of the body shops have pull pods.
Sure. Right?
Well, that's metal, and they're going right over that. So flat surface, plenty of space, get that verified, and then we could move on to the actual measurements of the vehicle.
Okay, now you mentioned flat space. Let's talk about some of the other parameters around that. So we want to make sure that we don't have a vehicle that's up or down a hill, correct? Right. Full tank of gas in a lot of situations.
A lot of them require full tank of gas. Some of them require a four-wheel alignment. Nissan's that requires both of those.
Verify tire pressure.
Verify tire pressure.
Height. So, and again, there's no universal requirement for that. That's going to be vehicle to vehicle to vehicle.
Absolutely.
So those are some important things, I think, because again, as we start, if maybe we're trying to rush this at the end of a job, we got to make sure we've got the fuel tank is full or whatever the parameters are. Make sure that all the golf clubs, any luggage that were left in there out of the vehicle, and whatever other parameters are required, because we're trying to get this vehicle kind of back to that zero plan, if you will.
I mean, and if you think about, just as an analogy, something that that the industry is a little bit more accustomed to at this point, think about occupant sensors.
Yeah.
In order to perform that calibration, you need weights, right, at certain specified amounts, so that you can go in and test that occupant sensor is not just reading correctly at 0, but it's also reading correctly at 75 pounds or whatever the spec may be. So we're talking about the same thing here. The manufacturer has determined that there are certain conditions that need to be met in order to achieve that calibration. And the full fuel tank, that's an awful lot of weight that is going to affect the ride height of the vehicle. It's going to affect the overall attitude of the vehicle, how it's sitting. So they need to recreate those conditions. They need you to recreate those conditions so that calibration will be successful.
So using your occupant classification sensor, you're teaching it what 0 pounds feels like, and you're teaching it what 70 pounds feels like, or whatever the different parameters are. So you're teaching it, this is what nothing feels like, and this is what something feels like.
Right.
So we're kind of doing the same thing here, right? We're teaching this vehicle that this is 300 millimeters in front, or 3,000 millimeters in front of the vehicle. This is at a particular height and is of a certain size. So that goes like, oh, I know what that is, and I can now judge that against something that's 50 feet in front or 100 feet.
You're giving it a point of reference.
Okay.
Absolutely.
Okay, so we looked at the procedure. We've got our full tank of fuel. We've got everything else. We've got the procedure. What are we going to do next on this vehicle?
Now, let's just dive into that for just a second, right? So we just spec that it's at a certain height. It's at 3,000 millimeters in front of the vehicle. It's on the center line because we're giving it a known reference point.
Yes.
What do you think happens if we set it at 2,500 millimeters and a couple inches lower?
So it's now going to think that 25 millimeters is 3,000 millimeters. And it's going to think whatever that height is
it's going to learn the module to the incorrect placement.
Correct. Yep. So you can get a successful calibration, given the wrong inputs, because it's trusting that you've given it the right inputs, right? So you can, just because you can get it to read in less space or at a different height or with a different size cone or whatever, that doesn't mean that you've successfully calibrated the vehicle according to the OE requirements.
I think
it just means you've tricked it.
I think that is a great point, and why we've talked about it. We've used it. I know others have used it. There's a YouTube video out there
Yep.
of a Honda
on the ladder
on a Honda lane watch vehicle.
Yeah.
Where, because the Honda lane watch, you can program it right on the instrument panel, right in the
right
vehicle. You don't need to do it any special fancy tools on it.
Right.
So this person prints off a little 3x5, 5x7, however big sheet, puts on a ladder. I don't think it's a Honda approved ladder. I don't think there's a part number for that. It's at an angle. It's at whatever height that he decided to put that at, and the system calibrates because again, it believes that you did the right thing when you said it's ready. And we know that that's, unless he's really, really, really good at math and he's got an algorithm all figured out with that angle and everything, which I doubt, chances are that system isn't calibrated properly.
Right.
And it's still going to see the car. I mean, it's the camera itself is going to work. It's going to see what it needs to see. It's just that when I put my right turn indicator on and I look at that, there's what, 2 yellows and a red, or 2 reds and a yellow. So now that says, hey, that vehicle is behind the yellow, when in fact it may not really be behind the yellow, because it thinks
it's not going to interpret that information correctly.
Yeah, that's a great problem. I'm glad you brought that up, because it's something that I think that can't be overlooked. So if somebody wanted to go look at that video, I think you just probably go do a Honda lane watch.
It'll come up,
search.
and it's got a lot of views, which is both scary and hilarious,
and a lot of subscribers too. So don't do that. Follow the OEM procedures. Use the proper size target boards in the proper location, because otherwise it's impossible to do it properly.
We could probably do a full series called the "Don't Do That" series.
We could do that.
Don't do that.
Good idea.
Yeah, just don't do that. Don't do that on my car.
Right.
That's fine.
Yeah.
Okay. All right. So thanks for bringing that up, Josh. I really appreciate it. That's some great
So
insight.
we've identified the space. We've identified the target that it needs. We've identified we have the correct target, right? But here's a little pro tip, because I've done it many times. Okay. We want to run a scan on the car before we set up all the measurements and targets. Okay. Because I've ran into many times where I'm going through a calibration, spend all the time measuring, set it up, click it to do the pre-scan or the post-scan at the end, and there's a problem with the module, something's not plugged in, or there's an additional repairs that need, right? So I went through the entire process for nothing, because I'm going to have to do it again. Right? So we want to hook up the tool to the vehicle, and we want to take a look, make sure everything's clean. Many makes and models won't even let you go any further if something's not. So from a field tip perspective, plug your tool in. Let's take a look prior to setting up and doing all the measuring.
Make sure it's calibration ready.
Make sure it's calibration ready. Absolutely. Because you will find
calibration ready.
Many times it's not. And then you have to go through the whole process again. Right? So we've done that, right? We're ready to get going on this specific make and model, right? And many of them out there, you know, people think we're using these high technology to do the measurements. Well, most of them start with the plumb bob.
That seems pretty advanced.
Yeah, I think they built pyramids with this or something, didn't they? You know, they're hanging on. So this one specifically, most calibrations start with identifying the center line of the vehicle.
Makes sense.
And everything is based off of that. Now, granted, again, all make and model specific, right?
So before you go any further, because say that one more time, it starts with the center line of the vehicle, correct?
Yep.
Because that's kind of where we need to be, right? That's all going to be based off of that. So if my structure isn't correct, I got a problem. If my steering suspension angles aren't correct and the vehicle's going down the road not how it should be, I got a problem. So three-dimensional measuring, pretty important for when it comes to ADAS. Is that correct? Is that fair to say?
Well, absolutely. Yeah, there's an assumption, right? Oftentimes, the center line is being derived by the center of the emblem on the front of the vehicle. Well, if the emblem isn't actually in the center of the vehicle because structure is off, because the bumper cover wasn't installed correctly, whatever the case may be, yeah, you're starting off with a bad input.
Garbage in, garbage out.
Right.
Okay. All right. Sorry to interrupt you.
Might as well just eyeball the measurements.
I think all vehicles involved in collision should get a measurement tool.
Absolutely.
100%.
It's impossible to repair a vehicle properly without three-dimensional measurement.
So this one is straight. We've put it on a measuring system. It's straight. right? And so we need to find the center line of the vehicle. Many times through the procedure is done with the plumb bob off the emblem. Simplistically, what you're doing on the rear emblem and front emblem is you're finding the center line of the emblem and you're finding your point, right? I've already done this. It takes a few minutes for this thing to stop wiggling back and forth.
Yeah.
So I would suggest not doing it in a windy environment because it'll be very difficult to get this thing to stop and identify your points.
So you're saying the plumb bob is technically complicated to operate.
It's, yeah, this simple piece of machinery can give you some problems.
All right.
It can. And I've seen people in the field stop it with their hands and mark it. That's not the way this device works, right? So we need to identify in this specific instance 3 measuring points or marking points to determine the center line of the vehicle. We can't get the cameras back there, but I did the same process with the rear emblem and identified point A.
Okay.
We're going to do points A, B, and C. C will be the measuring site where the target goes, and then go from there. So I don't know if there's any questions so far where we're at in the process.
So what you're saying is you found the center line at the rear of the vehicle.
We found a center point.
Center point at the rear of the vehicle. You found a center point at the front of the vehicle.
Yeah.
And now what you've done next is you've laid a string out across those 2 points.
Across the 2 points. So what I did is you tape the string in the back, right, or the front, because this is the same way you find center line based on blind spot monitor too. It's not just the front of the vehicle, right?
Sure.
So I've taped it in back. I've thrown the string under the car, and we find the center point of the vehicle.
Okay. Very good. What are some things that can go wrong in that initial process?
Yeah. So I think the most common thing that I've seen out in the field, and you guys are welcome to add to it, is when they come to point B and they find their measurements, they're taping the string at point B to the floor.
What's wrong with that?
Well, what that does, that's creating a pivot point.
Okay.
Right. So as you pull your string out, it's an impossibility to determine whether it's in line without some kind of laser measuring
So if that's
system.
taped down to begin
I've got
with.
calibrated eyes. I can see that. Come on.
Calibrated eyes work?
Yeah.
Yeah, absolutely.
So if I've got that taped down, I don't know if this is going to be accurate over here, correct? So
Yeah,
versus
correct.
if I tape it in the back, run it through my point, and then take it here and secure it here, now I know I've got that straight line.
Absolutely. So what you want to do is you want to run it past. Don't tape it here in the front. You create a pivot point, which could create problems. Run it past and make sure that you're pulling it well past where your measurement line and point is going to be for your C point, where the target's going to go. And you lay it right over the mark here, tape it down, and you have yourself a straight line going down the middle of the vehicle.
If you're using a crooked string.
I haven't ran into a crooked string yet, but that would cause problems. But I think the most common problem in the field, what I have seen, comes from taping at the second point, creating that pivot point, and then moving further from there.
It makes sense. We've already talked about the importance of that vehicle structure being correct. Well, if I tape it there and my structure's no longer good.
Right.
And it's not just the center line. I know I've seen a lot of other ones that we have to run string along the side of the vehicle, set distance up on the side.
Yeah.
Same thing there. So it's not just for the center line. It's anytime I'm running strings out in front of the vehicle to kind of set up that location. Because again, like we've already kind of talked about, it all starts with that target being in the right location in correlation to that vehicle.
Right.
Or else I'm not going to get a calibration.
Yeah.
Right.
Okay. We did have one question that came in. I don't know if you guys can help out with this one or not. So it's not related necessarily to the technical aspects of it, but like when I'm building my repair plan, when I'm putting together everything I need to do on this, how do I account for my staff labor hours I'm associated? Where am I going to find this information and know that, you know what, I'm going to have to do all this work and calibrate this. Where do I even find that information? How do I determine that time?
That's I think we get that question a lot.
I bet you do.
Because it's not in databases that I'm aware of, right? Your estimating software today, I am unaware of it being specified based on labor hours of the operation.
And I don't know that it can be, because how I do this vehicle is going to vary greatly from how I do another vehicle. So there's definitely not going to be a static time. So what are we going to do?
This is going to sound terrible, but you're going to have to break it up based on judgment of your time, right? So what I would suggest is breaking it down by operation. You know, found center line of vehicle X amount of time, measured out X amount of time, did this X amount of time, right? Try and break it up through the procedures that you're performing. And then, rather than just one lump sum, one, it makes it easily digestible by the payee, and it really lays out what you've done to the vehicle.
Yeah, and it comes back to documentation.
Right back to documentation. Always.
And I think that's a great idea because it's not including the estimating guides, and none of what we're talking about are included operations for any replacement procedures. So it's not associated with any of that. So,
right.
But I really like that, breaking it up into each individual, from the procedures to the center line. Yeah, that's great.
Yeah.
And same thing if we're going to do a dynamic calibration. Again, I need to figure out, like, so we did some dynamic calibration yesterday. Well, shooting here. Well, I've got to get, down the road a little bit on the freeway, and then I got to drive down. I got to find a location where I can maintain whatever speed I'm telling, that tells me to.
Right.
The manuals, the information the provider, the OEM says it may take up to 10 minutes for the system to calibrate. So again, where it was, and there's multiple people in there.
That's a 10-minute timer that starts running when you actually achieve the initial criteria.
Right.
And I've got myself and a technician in the vehicle. So one of us is driving, the other one's operating a scan tool. So we're now trying to drive and operate the scan tool at the same time. So now those are all things I need to think about as I'm building that repair plan and figuring out what is going to be involved in this. Okay, cool.
And again, documentation.
Documentation.
That's right.
All right.
So document.
Okay, so we've got, we found the center line of the vehicle.
Found the center line.
And we know we're 3,000 millimeters. Is that correct?
Yeah. So depending on the make and model, right, it's all going to be different. Identify what length from point B to C is required. And that'll be clearly outlined in your procedure. There's going to be 2 measurements more times than not in every single one. You have a measurement from B to C, and then you're going to have a measurement height of the actual center line of the target from the floor, right?
Okay.
So identify what those 2 components are, and then you get your measuring tape out and start doing some measuring. A lot of times it's in metric, so I know body shop guys sometimes shy away from math, but we may have to do a little bit, or use Siri, and she'll tell you.
Yeah, we definitely have to do some math, and we're going to do another calibration for collision hub on some Ford 360-degree aiming mats, and there was a lot of measuring the wheel, the width of the wheels, and divide by 2, carry the 1. It's just
you got a calculator, right?
I'm not looking forward to that.
Okay,
it's gonna be challenging for me, but we'll get it done. Hopefully, we'll figure it out. So
yeah, so we identify the length, right, and then we have to put our target at the length. Now, I don't know if we can even get a shot of this specific stand. Hopefully, we can. This is a product that actually you can get directly from AirPro Diagnostics. This is going to work with your Toyotas, your Hondas, your Subarus, anything that would require the radar cone. Okay, this is a product that
turn your body.
Turn the what?
Your body a little bit there.
Turn the body.
Looking at your backside there.
Look at the backside. All right. All right. Sounds good. It's my first time on camera.
It's good. No, you're good. You're good.
Right? I'm not used to all this.
I understand.
I'm a body shop guy, right?
Well, last time he had his camera turned on that one time. Now he's got his body turned on.
I get everything backwards, right? So this is a product that we have. It's available to everybody. Go and reach out to us if you have the space and within your shop and you want to start doing some of these things in-house. It's an excellent way to not only ensure that the repairs are done correctly, because I don't think sending it to the dealer is necessarily a guarantee that it's getting done.
Sure.
We've talked about that before.
Right.
And then not only that, but it also gives you the ability to generate some revenue. A byproduct of doing the right thing is you get to make a little money at it. Right. So we've identified this. This has its own leveling system on it.
Let's talk about the unit itself a little bit more. Some of the features of the unit itself.
Yeah, absolutely.
There,
so
come this way.
This way.
Yeah, swing around a little bit.
All right. So this specific unit, as you see on the base, it has an adjustable base with 2 bubble levels. That lets you ensure that it is level. The target stand is level to the ground. Not everyone has this beautiful cement floor that you guys have.
That's
right? So you may have to make an adjustment there. It also has some windows in the top. I know we can't get that, but it allows you to identify the fact that it is straight on the string, and it allows you to make sure that you're on your exact mark.
I like that. Okay.
So, and one of the things that this has been designed with is the front of the cone is actually in line with the front of the base. So as you line it up, you know that it's symmetrical from top down.
Okay, got it.
So, and then
So then we know that that's 3,000.
Yeah, yeah.
Right.
And then you could adjust it based on whatever height is needed through the specific manufacturer guidelines. So,
Okay.
And to that end, the adjustment rod is actually an extension of the center point of the cone.
correct.
And when you're taking the measurement for the height of the cone, it's generally that it needs to be the center of the cone.
Yes.
And so if you measure from here to the floor, you're getting that distance as well.
Yeah.
Which is not always accounted for in these products.
I've seen a lot of these out in the field, and I know a lot of the viewers have too. You know, they're made out of PVC pipe, or one's made out of about a 4-inch by 4-inch wooden base that goes up. It's not very stable, so it's a good unit to have in your shop.
Okay. Cool. What are some of the common issues that I might have as a technician when I've got something like this? What might you see me doing incorrectly if I were to set this up?
You know, there's not a lot that can go wrong here.
Okay.
Okay. The things that go wrong are generally human error in measurements. You know, they've measured incorrectly. Maybe they put the cone on upside down. You know, it goes a specific direction, right? And you can flip it by taking the cap off and flipping it. But this right here, not a lot can go wrong.
Okay.
I mean, if you're messing this up, we probably made some mistakes in the previous steps also.
Sure.
Right.
Okay. Okay. So this cone looks a lot different than a lot of the targets I see.
Yeah.
Just for those of the viewers that may not be as familiar, what's the difference between like a cone like this and a target? What's the difference?
Yeah. So it's the operational system on the vehicle,
Okay.
right? You know, these cones are built for radars, right? And they're meant to reflect and send a signal back to the car. Targets generally are meant for cameras, right? That they're actually seeing something, the target at a specific length and a specific system. I don't know if you want to add to that, but that's pretty much my explanation when people ask.
Yeah, and I think that about sums it up. I mean, if you think about it in terms of the camera, something that's becoming more commonplace right now. I mean, we encountered it last night when we went to grab a bite to eat at the end of the day, right? There were the little QR codes on the table, right? So if you think about the camera target, kind of along the lines of a QR code, it's got a known signature, right? Those shapes, those dimensions are a known expected shape and dimension that tell the camera what it needs to know, right? So along those lines, that's what you're getting when you're using a target for a forward-facing camera or something like that. Whereas to Eric's point, this is meant just to take that radar signal and turn around and send it back. And so it's measuring the amount of signal that's coming back and the speed at which it's coming back, or the time that it takes to return, because it knows, because it trusts, again, that we put it where we were supposed to. It knows what it should get. And it's verifying that and saying, okay, I got it. I'm good to go.
Okay.
Now I know what to expect when I drive down the road.
That's an excellent point. And they just know there are some makes and models that will allow you to adjust the radar. It will actually tell you how many degrees it is off one way or another, and you do have adjustments at the radar to make it, right? So some of these systems are as simple as learning to where the point is, but some of them give you an identification of the degrees it's off and allows you to make that adjustment one way or another. Because many of these just sit on a bracket, right?
Right.
So maybe you're adjusting the bracket. I mean, it's metal on metal on metal.
Yeah.
Right. So there may be just some adjustments needed.
Sure.
And as long as you're not making it work, or to your point, tricking it,
right.
You know, that those adjustments may be necessary through the process.
Now you mentioned, and maybe you said it, I was checking out the Q&A or something, but you talked about the floor pots from some shops and, you know, other metal in the background. What could potentially go wrong with that? I don't know if you covered that or not.
Yeah, I think just simplistically, it could create that reflection, right? Maybe the radar bounces off of that piece of metal rather than your target and sends a signal back, right? And it would be the equivalent of having your cone in the wrong spot and still tricking the system to thinking it is. One thing that a lot of people in the field overlook are the things behind the target. That's why it's so important to have that necessary required space that the manufacturer wants, of clear space because behind the target can surely affect not only radars, but in many cases the windshield cameras, because it's identifying different things, confusing the system.
And if you think about, I mean, if you could see the signal that is coming out of the radar, right? This is not something that looks like a laser pointer.
Right.
You know, this is a little bit wider band. It's a wider spread because it's meant to be seeing what's in front of the vehicle as you drive down the road, and it's just trying to identify a known point or an anticipated point. But if you go back to having a piece of metal on the floor or something like that, that wider band of that signal is going to catch that. And if it manages to be at just the right angle where it can send some of that signal back and it catches it, now it's confused. It's thinking, well, is the return time from this point on the floor the right return time, or is the return time from the actual cone the correct, you know, signal?
Right.
So it's going to confuse it.
Sure. Now, one thing that we talked about the string and being off a degree or two one way or the other, or maybe a tenth of a degree, and that presenting some challenges. How big of an issue is that? We kind of went past it. We missed that part of it. But if I'm off by a half a degree one way or the other,
Sure.
Could that be a problem for me?
Absolutely. So, I mean, you think about point B,
Yep.
right? So you get point B wrong by a couple of millimeters,
Sure.
to the left or to the right. Well, as you extend the string out, or to Eric's point, you're the guy that takes it at point B.
Mm-hmm.
And now you extend your string out 3,000 millimeters, and in doing so, you've gone off a couple of degrees to the left or to the right. Well, now imagine you're on the highway,
Yep.
and you're following at a safe distance of, let's say, 3 or 4 car lengths. So what are we talking, 60 or 80 feet?
Mm-hmm.
You know, so what is this much out here at 3,000 millimeters, or, you know, roughly 10 feet? By the time you've gone out 80 feet, it's going to look a little different. And now all of a sudden, instead of perhaps looking in directly ahead of you in your lane, it's now seeing a vehicle in the lane to the left or a vehicle in the lane to the right, because that's where it's pointing, or that's where it believes the center is.
That sounds like it could be a problem.
Well, it's life or death.
It is life or death.
You know, I say this, there's no gray area there, right? These systems have to operate as designed by the manufacturer in a subsequent wreck, because they are designed to save lives.
Yes.
If we can't verify that, if you're not confident in the procedure you're doing, not confident in the tool you're using at the car, we haven't even talked about, you know, you could be doing this with remote diagnostics. You do the setup, we'll make sure the system's operating correctly, and we'll give you your verification.
Let's talk about that. What does that process look like?
Yeah, it's what we did here, because this is just math, right? You don't have to understand the system of the vehicle to set this up. Right. Anyone can set this up. You're doing math.
Read the instructions and follow them.
Absolutely. Like putting together a puzzle, right? But once we get into the system and we start doing the calibration, if it fails, if it passes, what have you, that's where the experts come in, and they can tell you XYZ is wrong.
Right.
This is off this much. Try this. This is not plugged in. You have an expert with the proper software on the vehicle, ensuring the safety system at that time has been learned correctly, and it's at that time operating as designed by the manufacturer, right? You don't have to be an expert in all make and models anymore, and you shouldn't be obligated to be so. Remote diagnostics will allow you to essentially be your own in-house expert on most all make and models, and have that comfortable feeling at the end that it was done accurately, correctly, and the safety systems, which what it all comes back to, are operating as designed.
And you heard him say at that time, right?
Yeah.
So this is about a snapshot in time that we're verifying that. Well, in working with AirPro Diagnostics, we're also recording the screen session that all of this is taking place in.
Okay.
So you've set it up, you've done the math, we've walked you through and made sure that all of that is correct, because we've picked up the phone and called you to verify that you did these measurements, you followed this procedure, it's 3,000 millimeters, so on and so forth. And you're saying, yeah, absolutely, I'd check, right? And we've logged into the tool now, and we've taken over, and we've performed the calibration by allowing the system to recognize that everything's ready, and now's the time to learn what it needs to learn.
Okay.
And we've recorded both that phone call and that screen session and we've documented that, and we have record of that, so that we can be there to back you up at a later date if there was ever a question about whether or not you did what you were supposed to do.
Yeah.
We can demonstrate that not only did you do what you needed to do because you walked through it on the phone with us, but we did what we needed to do, and we've got all of that documented.
All right, we did have another question coming at relative to what we talked about a little bit earlier with the floor pods. If I've got like a grate and like a washroom or something like that, can I cover that with something to eliminate that potential or not?
An excellent question, and I always shy away from answering it.
Okay.
Right. The truth is I don't know.
Sure.
Right. The manufacturer doesn't typically say cover it up with X, Y, Z.
Right.
I would say that if you do have an issue, let's address each individual issue as you have at the shop.
Okay.
And then the shop can make the best decision from there. My gut feeling would say that it would cover that reflection and you would be fine.
Sure.
But just from an Air Pro perspective, I would not push you one way or the other.
I can appreciate that. I think from a best case scenario,
yeah,
just try to eliminate that variable.
Try and eliminate the variable,
Absolutely.
and then you can make a decision as a shop whether or not it's, or maybe you could even submit a question to the specific manufacturers and say, if this is covered up, is that okay? And they may respond and say, absolutely, no problem.
So subscribe to Pick-a-Tech, and
there you go.
I was going to say, you can probably help with that.
And then we can see if we can get an answer for that.
That's an excellent.
Did you just answer your own question?
I did. Yeah, I'll call myself later. I'll call Larry after the break and ask.
Yeah. So that's what I would.
Larry, get on that.
Answering.
All right. Again, if anybody's got any questions, feel free to chime in.
We're not done.
No, I know. I just want to make sure that everyone knows that we got
more steps.
But wait, there's more.
But wait, there's more. We've successfully calibrated the vehicle. Right, click the button. Calibration successful. Next steps.
Am I the only one that wants to say it slices, it dices?
It slices, it dices, it juliennes. But you got to get the next step done, and the next step is a test drive.
Yep.
Right. We got to make sure we're test driving our cars. Get it out there. I'm not suggesting you're testing the automatic electronic braking. Take the wheel and sail in there. But we want to get the car driven. We want to make sure all the modules are waking up, right? And make sure the car is activating what needs to be activated. Take it for a good test drive. Get it back to the shop and hook your tool up again and do another scan.
Okay.
Right.
So a few things about that that kind of get me thinking a little bit about it. Again, that safety test drive is done, number one, again, for safety. Before I give these keys back to my customer,
Absolutely.
I want to make sure that system works as designed. In order for me to make sure that system works as designed, I need to know how that system is supposed to work. So I need to make sure that I've done my due diligence on what exactly, does this have lane keep assist? Does it have lane departure? Does it have both?
Right.
Does it have,
is it only blind spot?
Is it only blind spot? So I need to understand what the vehicle's got on it, and then how the system's going to operate. I use the adaptive cruise control scenario all the time, because you're going to often have, a minimum of 2 or 3 distance settings on that. So you want to make sure that each one of those are working each and every time.
Yep.
Again, none of these are included operations either. These are all, subsequent to that need to be included in that repair plan. So if it's not included operation, chances are that one good, I think, best practice would be, rather than me working with, Joe Public driving in front of me, maybe it'd be better if I had somebody in front of me that knows that I'm testing the adaptive cruise control, why I'm getting closer and farther and kind of coming. So that might be not a bad idea.
Sure.
I certainly think about like the rear cross traffic alert. Once I've done my repairs, once I've done my calibration on that, I don't want to be pulling out in front of somebody at the superstore parking lot. I want to make sure that somebody knows that I'm going to be doing this testing. So I may need 2 vehicles in a lot of cases.
Right.
Again, all not included operations, but absolutely impaired. So what are some things if I'm test driving this vehicle? So on this particular vehicle, we've got this sensor on here. What am I testing, and what does that look like from me as the driver going down the vehicle? What am I trying to do? What do I want to do?
Yeah, so this specific system would be the adaptive cruise.
Yep.
Right. So you're going to get up to a speed where you have the ability to engage the cruise control.
Not over the speed limit.
Over the speed limit. Make sure you're at a speed where you can engage the cruise control and make sure it's operating. But you got to know, when we talk about operating as designed, make sure you know what that is.
Right.
You alluded to it earlier. Make sure you know what it's supposed to be doing. Right. Test the system, make sure no lights come on, right? Make sure you don't have any indicators, and essentially just test the overall drivability of the vehicle.
So again, you mentioned we could test drive, adaptive cruise control, blind spots, one we can test real easy, lane keep assist.
Yeah.
Probably don't want to be testing automatic emergency braking.
I would
like
highly suggest do not.
Probably kind of like not wanting to test a new airbag that we put in there, right? We're just
Yeah,
trust that we've done everything properly. We've got our documentation.
It's fair.
Probably not going to test our pedestrian protection system. Is another probably thing that we don't want. Are there any other systems that we want to check, or maybe we don't want to check? They just in general, I think that pedestrian protection, automatic emergency braking / collision warning are probably a couple that we're probably not going to be able to test.
You'll be able to. I mean, you'll know if the lights are coming on, right? If there's anything just so far outside of spec that it's giving you some sort of visual indicator.
Something's weird.
Yeah, something's weird, right? It's you're not going to be able to see what's happening on the internal components of the vehicle. That's why we hook up scan tools, right? And and we have proper technicians on it with the proper software. Leave that to us.
Okay.
But you're just doing a drive verification, just as you should be doing on any repair you complete within your facility. Right. Test drives are incredibly important, and regardless of the repair you make, you should be given a good test drive and a good function test through the process.
And this test drive at this point, I mean, test drive is a term or an expectation in the repair process. It's been around for a long time.
Yeah.
But for a long time, it meant basically a shakedown, right? It meant taking it around the block just to make sure that the steering wheel's straight ahead, listen for squeaks and rattles, that sort of thing, right? Make sure that it doesn't have a misfire that was created as part of the repair process or some other thing like that, right? And that was a fairly straightforward operation to achieve almost regardless of where you live, because you can get that much out, anywhere. Now you're talking about something that's much more involved, because as we talked about before, there are certain certain conditions that need to be met, certain speeds you have to achieve, et cetera, et cetera. And so depending on where you are, if you're in a major metro area, that could be a fairly involved operation in order to achieve those results. So, one of our friends in the industry, and it's now part of the CIC definitions and that sort of thing, put together a definition for the dynamic systems verification. Okay. As a way to distinguish the difference between, the traditional test drive and what we're now talking about trying to achieve. And a dynamic systems verification is really just meant to explain these are dynamic systems and they require certain conditions, and you want to verify that those systems are operating correctly.
Well, and let's be honest, there's safety inspections.
Absolutely.
We can call it a test drive or a dynamic
systems verification,
but the reality of it is we're doing a safety check of this vehicle to give us a level of confidence that when I give Eric his keys back and he puts his adaptive cruise control on, it's going to work as designed.
Right.
Now, back to the question around automatic emergency braking, pedestrian protection. A lot of these systems are kind of tied together in a lot of cases, correct? Mm-hmm. So if I've got adaptive cruise control on a vehicle with automatic emergency braking, chances are I'm using a lot of the same components of that system. So if I calibrate properly the adaptive cruise control system, will that give me any peace of mind that it's more likely that the automatic emergency braking is going to work as designed?
I think that's a reasonable,
stress is not foolproof, but I'm
right,
saying
by no means is it concrete, but I think you're making a reasonable connection there, right? The terminology that I heard getting used a lot, I think it was at the last SEMA in different technical presentations, was sensor fusion. And what ultimately they were getting at is, you don't need a radar sensor for automatic emergency braking and another radar sensor for another system and another for adaptive cruise control and another radar sensor for this other function. You got one radar sensor, and they're going to, in many cases, use that as an input for multiple different systems. And I mean, this is not a new condition to use one input for multiple outputs or multiple actions. If you think about wheel speed sensors, for a very long time, wheel speed sensors have been a source of vehicle speed information, in addition to a vital input for anti-lock braking, right? So same kind of deal here, where you're using multiple sensors to achieve an even greater number of systems and operations.
Okay, cool. We did have a question come in while we were chatting with relation regard to the cone. What other systems does this work on? Can you give us a little rundown of what I can use this on?
Yeah, we have a list. You're welcome to reach out to us. We'll get you the list. But for blind spots, front radars, you know, those are typically what's using the radar technology, right? So if it's utilizing the radar technology, this radar cone will produce the results as designed by the manufacturer. So front radars, blind spots, with the exception of Nissan front radars, because as we all know, it requires a much larger target with mirrors and things of that nature. Okay. So we do have a list. Go ahead and reach out to us. We'll get you the list if you're looking for it.
Where should I reach out? Where am I going to go to get that?
You can go directly to our website and submit an inquiry.
Okay.
Okay. Is our contact information going to be presented at the end, Jason?
Well, we don't have a slide for it, so no. But
no.
But you can definitely email Jason at collisionhub.com or Kristen at collisionhub.com.
Or email myself, eric.n@airprodiag.com. And I'll get you to the right.
Now,
in
some of the previous episodes that we did have a screen on there. So if you want to go back and watch the previous webinars, that's also available there. So, all right, we got a few more minutes for questions. If anybody has anything, we'd love to get your feedback. We've got these two captive here today.
Yeah.
They're not going anywhere for the rest of the afternoon.
We're stuck here in Arkansas for at least the rest of the day.
No flights out. I think it's worth mentioning, though, as we took a look at the process, for those who are watching, really think about, is this too complicated of a process to do within your own shop, right? It's this part of the process is fairly simplistic. By doing this and partnering with a remote diagnostics company, you can be doing this under your roof, right? And how does that help? It helps with cycle time. It helps with the KPIs. If your shop is being held to those KPI standards that many of them are,
sure,
based on the payee, it will help there. It'll help drive revenue, but most importantly, it'll help ensure that the safety systems are being addressed correctly, because I could tell you from experience, it's not always done so.
Sure.
When you outsource it somewhere.
When you outsource it somewhere
outside
else.
under your roof.
And I think it gives you that peace of mind, because again, it was done, and you want something done right, you do it yourself, right? Now, granted, you're partnering with somebody to help you along the way, but if we take this vehicle and send it wherever, and it comes back, we weren't involved in the process. We don't know that they didn't mark B and then bring C. We don't know that. So at least if we do it, we've got that peace of mind that we know that we measured it properly, we verified it. I think that's a great point.
And I think it was mentioned in our last webinar. I think Bradshaw mentioned it. Is even when he sends his to the dealer, he's providing the procedure to the dealer and requesting photos of proof that they followed it.
Yeah.
Right. So if you are going to use a third party, it's going to go outside of your building. Make sure that they're taking some form of documentation that they can give to you at any given request that it was followed correctly. Because if you're doing this in your shop, surely you should be taking photos that you followed the process and documenting correctly. And we should hold the third parties to those standards also.
So we have another question coming in, specifically more to the model, to the AirPro model.
Mm-hmm.
Number one, Canada coverage. Are we in Canada?
Yep, we're in Canada.
What's the process if I want to become an AirPro customer? What is the process I would use in Canada specifically, but I think in the U.S. as well? What's the process I would use to become an AirPro customer?
Again, you go directly to our website, right? Or contact me, or contact Josh. You can contact anyone within our organization if you want to become a customer, and we will get you set up. It's a very simple process. We'll connect you with our sales team. We'll get the necessary paperwork filled out, and it ships directly to your door. At that point, we'll go through whatever training is necessary within your facility and who needs to learn how to utilize the device, and it's from there. I like to say, if you could plug a toaster in, you could operate the AirPro device. It's that simple.
Subscription per use basis. What's that?
Yeah, it's a pay per drink model, right? As many third-party remote diagnostic companies are. There's different prices based on the service that you're requesting, which we could surely get to anyone interested. We can get you all that information.
Yep.
But there's different services that we provide, and each come at a different price point.
Okay. Very good. Well, I'm not seeing any other questions coming in right now. So I think we can wrap it up here.
Perfect.
Guys, really appreciate you
Absolutely.
getting out of your house and coming down to Arkansas.
Yeah.
It's thank you
good to
to
get on a
everybody.
plane.
Thank you for everybody for joining us today. Again, if you've got any questions afterwards, jason@collisionhub.com. Email me. I'll forward on to these guys or somebody else from the AirPro team. Website is
airprodiagnostics.com.
piece of cake. All right. So with that, until next time, thanks everybody, and hope you have a great rest of your day.
Thanks.
Thanks all.